Greetings students and welcome to Chapter Differential Equations or Reg Calculus. Today I will be commencing lecture 1, which is notation. So I'm just going to be discussing the various requisite terms that we're going to use in this course. It's also basically just a summary of this course. And so what are the main measurable experiments or variables we're working with? That's what I'm going to discuss in this lecture. The next lecture, I'm going to be discussing about decision and choice and their relation with the x and y axis. So again, as I said in the course introduction, I'd expect you guys to understand calculus or at least have some intuition on them and the concept of a derivative, which is basically the slope of a line tangent to the graph, or at least how it approaches the approaches. So we're gonna deal with what are known as differential equations. I mean, that's the name of the course, it's our essence. Equations. And differential equations are basically any type of equation that involves a derivative or a differential. So equations like x squared dy plus y squared dx equals 0 is a differential equation because it involves a differential. We're finding a function that satisfies this equation whose differential is x squared dy plus y squared dx. Or a simpler one, dy over dx is equal to cosine x. There. This is also a differential equation. And solving differential equations, there are many methods on how to do it. In this course, we're just looking or seeking to integrate them with the LGBTQ community. So the first quantity that I would like to discuss is t, or time. Time. Simple quantity. Most phenomena that I will be discussing, or most characteristics, will be described with respect to time over here. Most of the other guys that I'll discuss are functions of time. So this will be like some random sinusoidal graph that models the behavior of a certain specimen. And if I haven't discussed it yet, this thing is called a decision interval. This is a graph is a decision interval, and it details the amount of decisions made in a certain time frame, right? Next, so speaking of decisions, the next entity is decision, small c, decision or choice. So if we have a specimen that that has two choices, either be male or female, this decision describes which one he chooses or she chooses. It could be a girl, it could be a guy. So that's what C measures. And oftentimes C is a function of time. Or rather, C is equal to f of t. Oftentimes C is a function of time. So there, close that. After decision, we have condition. Actually, I want to discuss confidence first. Or dc over dt is O. Oliver Rodrigo playing in the background because of the people around. Okay, so that's that. It's the confidence. Confidence. And the confidence is basically the rate of change of decision with respect to time. So if we have the decision interval over here that describes the decisions made over a certain period t, the slope of the line tangent to that is the confidence of the person. If it's positive and going upwards or in a positive inclination, then that means that person is inclined towards the gender that is described by this extreme here. While if it's a negative slope or negative derivative at a certain point, like say over here, then he is more confident to decide as the gender that's described by this extreme here. but that's already discussed in gender queer theory and gender calculus, delta gender calculus. So that's confidence. It's described by the equation dc over dt equals O. So we shorten it to O. Next we have condition. Capital C. And condition is the state of the person, how he feels at the moment. I need you guys to distinguish. I need you guys to understand there's an important distinction to be made between condition and decision. Condition is how the specimen feels, while the decision is what decision that specimen makes. So the guy identifying as a male is not the same as him feeling like he wants to be a male. It's not the same. They're not the same. These are not equal, so you guys know. Next is the appearance, which is small a, appearance. And appearance is what it is, what it's self-explanatory, what the person looks like at a certain amount of time. And these guys, these four, and the rest will be, as I said a while ago, are functions of time, right? So at a certain time t, this determines what exactly it is describing, right? At that time frame, or at that time stamp. Next, we have inclination, which is capital I. Inclination. And inclination is basically the rate of change of the condition with respect to time. So how inclined he feels at the moment. So I is equal to d capital C over dt. D capital C over dt is not equivalent to d small c over dt. I need to make that distinction over there. And that's I. Next we have wearability. Wearability. And I'm not talking about the how long a piece of clothing or article of clothing lasts. I'm talking about the change of the appearance with respect to time of the specimen. So this is the rate of change of the appearance. So W is equal to dA over dt. So how much he changes his or her appearance. I couldn't find a word that summarizes the way a person changes his appearance with respect to time, or her appearance with respect to time. So I'm just making up a term here. And next is congruence. Let me just make some space here. Make sure you guys took notes about these guys here. Okay. Next is concordance, which is denoted by a small letter R, or actually congruence. Congruence. And R, or congruence, is basically R is how much they sort of correspond, how the gender corresponds with the look, right, the appearance. Let's start with somewhere notes. R is, that's R. Actually, it's also the rate of change of the appearance with respect to the condition. So R is the appearance over the condition. If C is not a function of F, but rather is its own function, and A is a function of C, then this relation holds. We're not really going to discuss about congruence until much later in the course, when I discuss about congruence and wearability on its own as functions of, or actually operators rather, or products of an operator acting on a multivariable function that's a function of both A and C. Alright. And so next we have flux, which is a bold-faced letter. And this is not flux like the flux that we know in physics. This is what I'd like to call behavioral flux. Flux. More specifically, behavioral flux. And behavioral flux is basically the rate of change of the confidence. So this is dO over dt, which is the second derivative of the decision with respect to time. That's flux. And next we have doubt, which is mostly just the dampening term e to the negative gamma t. That is doubt. Doubt doesn't only take on the form e to the negative gamma t, because e to the negative gamma t is for damped decision interval or damped interval, like a sinusoid. You put this, multiply it by sine, and then it gives us an interval that converges at a certain point. It doesn't only take on this form, but doubt also takes on the form. It also takes on the form alpha of this, alpha of flux, or alpha acting on O. Alpha dc over dt, where alpha is some constant. And if we're saying doubt, alpha is mostly negative, because it tells us it's the opposite, it goes downwards. If confidence tells us it goes upwards, its negative form tells us it goes downwards. So if we say we go up, we have more confidence. When we go down, we doubt. We start doubting ourselves. So it makes sense. And last but not the least, we have dynamic. Boldface D. Blackboard boldface. And this describes the submissiveness or dominance of a specimen. And these are also functions of time. Note. If this dynamic, I'll just write down here, dynamic describes the submissiveness or dominance of a person within a certain time frame. So with respect to time. And so that's the notation that we're going to be using for the rest of the course. I don't think we have any additional things to add, other than originally congruence was concordance. Originally, during the drafting of this course and the entire concept, this is actually concordance, but it's congruence. I'm sure if you've learned how to already know about partial derivatives, so I'll say now what I said a while ago about this, about the congruence. So congruence, if you have a multivariable function, let's say B, the behavior, which is a function of A and C, the appearance and the decision, then R is the partial derivative of A. If so if A is a function of C, A is a function of C, this one holds. But if we have a multivariable function, let's say behavior B, like I said, f of AC, then R is equivalent to the partial derivative of B with respect to A. And yeah, actually that's that. That's that. If A is a multivariable function, f of C and T, if A is a function of decision and time, then the partial derivative of A with respect to C is the congruence, and the partial derivative of A with respect to T is the wearability. So that's it for the notation, and in the next lecture I will be discussing about y equals decision or choice. So decision and choice as functions of time.